Welcome to John's Maths book. In this video, we're going to be looking at what rational and irrational numbers are. We'll start with rational numbers. A rational number can be expressed as a fraction of two integers. If it's a decimal number, then the decimal number terminates or repeats. Now, what we mean by that is the mantissa, or the numbers after the decimal point, terminate or repeat. So let's take a look at some examples of rational numbers. So if we take our first example of 1.5, now 1.5 can also be expressed as 1.5 or 3/2. So as we can see, we can express it as a fraction of two integers, 3/2. 1/4 or a quarter is a fraction of two integers, so it's a rational number. It can also be expressed as 0.25 in decimals, where the mantissa, or the numbers after the decimal point, terminate. So it's 0.25. In our third example, 0.333 recurring. Now, this is also a rational number because it can be expressed as a fraction and the numbers after the decimal point, or the mantissa, repeat. So the fraction, when it's expressed as a fraction of two integers, it can be expressed as 1/3. And in our final example of rational numbers, we're looking at 7 divided by 5. So this is obviously a rational number because it can be expressed as a fraction of two integers. It's an improper fraction, and it can be expressed as 1 2/5. If we want the decimal of 7 divided by 5, we can express it as 1.4. So when we express it as 1.4, the decimal part, or the mantissa, is just 4, so it terminates. So therefore it's a rational number. So with irrational numbers, they cannot be expressed as a fraction, and when expressed as a decimal, the decimal part of the number, or the mantissa, does not terminate or repeat. For example, the square root of 2. Now, as a decimal, if we actually take the square root of 2, it works out to be something like 1.4142135, and it just goes on. So this is known as an irrational number because the decimal part does not repeat or terminate. If we look at the value of pi, now pi is the ratio of the circumference of a circle to the diameter. We often use an abbreviation of pi as 22 divided by 7, but that is an abbreviation. It's not the exact value of pi, because the exact value of pi is the decimal starts as 3.142, and it just carries on. It doesn't terminate or repeat. But for convenience, we use the abbreviated fraction of 22 divided by 7. Now, in our third example, we're looking at the cubed root of 3. Now, the cube root of 3 is equal to 1.44249 ... Again, the decimal part of the mantissa does not repeat or terminate, and all roots, all cube roots in this case, that are not perfect cubes will all be irrational numbers, And I should also say that square roots, where they're not perfect squares, for example 2, will all be irrational numbers. So other examples of square roots that are irrational numbers are the square root of 3. The square root of 4 is a perfect square, so that's a rational number. So the square root of 5, the square root of 6, these are all irrational numbers, because when they're expressed as, they cannot be expressed as a fraction of 2 integers, and the decimal numbers do not terminate or repeat in the mantissa. So in our final example, here we have 1.763936, and it just goes on. I mean, this is also an irrational number, because as we saw from above, the mantissa part, or the part after the decimal point, does not repeat or terminate. So that includes this video on rational and irrational numbers. If you like these videos, then please like, subscribe, comment, and share as usual.